Looking for one last boost to your studies before the exam? Try our revision package. For just $10, you get 7 days access to our entire ACCA Performance Management exam course. Go through our comprehensive playlist, picking and choosing which concepts you want to cover and which questions you want to practice. Use our filters to revise the most commonly tested and difficult concepts. Go through our question videos for that all-important exam practice. Your choice. Hopefully, it'll be the final stimulus that you need to go on to ace the exam. And now, on to our video. Hello everyone. In today's video, we'll be trying yet another past paper question for the ACCA Performance Management exam. The question we're doing today is from the September-December 2021 past paper. It's scenario 1 from section C. And the topic of the question is basically your linear programming. So without any further ado, let's head into the question. As always, we're going to start with the requirements. So the requirement for part A says, for 7 marks, part 1, calculate the optimum production plan and the resulting total contribution earned for March, assuming that the order with Run Wild is supplied in full. And then there's a second part later on for 4 marks. So 7 marks for a calculation. What's the calculation? Calculating the optimum production plan. So in order to calculate the optimum production plan, we'll need to follow the steps. We'll need to find the contribution per unit and use that to find the contribution per limiting factor, rank according to that factor, and produce in that order based on the ranking. Now, of course, they want the total contribution earned, and they want us to assume that the order with Run Wild is supplied in full. Now, this is a typical type of past paper question in the exam that not only is there the ranking that we need to do, but there'll also be an order already, and that order will probably be something that contradicts the ranking. But we need to fulfill the order first and then go and do the fulfillment according to the ranking that we determined. So let's head to the question and read through it. Typically this calculation takes a bit of time, so we need to be very comfortable with it so that we can perform it quickly and efficiently, so as not to take more than our allotted time in the exam. So it says Bella Houston Co. manufactures 3 types of running shoes which it sells to sports clothing retailers: road, which are for running on roads; spikes, which are used for racing on athletics tracks; and trail, which are used for running off-road in rural locations. Each of these products use differing amounts of resources. Financial information is given below. So the first paragraph is basically fluff. We don't need to worry about it. Then we have the table, which is where we'll do most of our calculation from. After the table, it says fixed overheads are absorbed at a rate of $4 per direct labor hour, and Bella Houston uses a just-in-time production system. Demand and resource availability for March. Demand for the 3 products for the month of March is expected to be, they've given us the amounts in the table, and it says Bella Houston has received a special order from Run Wild, which is not included in the demand estimates, so it's separate. Run Wild are a major sports retailer who have an extensive customer base and are known for stocking the most popular brands of sportswear. The order is to supply a maximum of 200 pairs of each type of shoe at a discount of $8 on the standard selling price. So we need to make sure that we take this discount of $8 in the price when we calculate the contribution for the demand related sales. So that's one part, and there's 200 pairs for each type of shoe. Run Wild will charge a financial penalty if the order is not complete. If the order is successful, they will be keen to enter into a regular supplier contract. Usually, Bella Houston has sufficient resources to meet production. However, during March, the maximum availability for the following resources has been identified. So for meters, it's 7,200 meters. For direct labor, it's 6,900. And for machine time, it's 1,815. This is what we need in order to find our limiting factor. So it's going to be either materials, labor hours, or machine time. And the way we'll do the calculation is we'll take the total number of pairs we need to make for each shoe and find how many meters that will require, how many labor hours it will require, how many machine hours it will require. And how do we know how to find that information? Well, we have the number of pairs given in the table here, plus the 200 for each of the pairs for the run wild order, and we can find the meters per unit, or pair, the labor hours per pair and machine hours per pair from the table here. Now from the table it says selling price per pair of shoes. So this table is for one pair of shoes, not one individual unit, one pair of shoes. Okay, so let's write down our answer in our table. This is, first we always label our answer, so this is scenario 1, and this is going to be part A, part 1. Please remember, whenever there's multiple parts given for like A1, A2, remember to label 1 and 2 separately so that the marker knows where your answer for one part starts and where it ends. So first we need to find the materials needed per pair for road, spikes, trails, and direct labor hours and machine hours. So we'll make a table. We have road, spikes, and trail. We'll make this bold as it's a heading and we'll align it towards the center. Okay, so first we need to find the materials per, or meters per unit for materials, or meters per pair rather. In this case we should be more specific with our wording. We'll have the labor hours per pair and we'll have the machine hours per pair. So how will we calculate it? Well, for road it says the total material cost is $7.5, and if the cost is $5 per meter, we can find how many meters that comprises. We take the 7.5 and divide by 5, meaning we have 1.5 meters per pair of material required, because 1.5 into 1.5 meters times $5 per meter gives us the total cost of $7.5 per pair. And we'll follow the same logic for spikes, which will be 3/5, and for trail, which will be 6/5. After that, for labor hours, $7 per hour, and for one pair it's $7 for road, so it's basically 1 hour, 7/7. Same logic here, it will be 10.5/7, which will give us 1.5. And for the trail, again it's 7/7, which gives us 1. Machine hours per pair, same logic, 4/10 for road, 2/10 for spikes, and 3/10 for trail. So now we have the amounts per individual pair. Now we'll make a separate table, which will be for our, or rather not separate table, but we'll have the number of pairs required. So number of pairs, we have the external demand, and we have the number of pairs for the road wild order. So road wild order. We'll keep these two amounts separate in case we need to refer to them separately for some calculations. So if we go down in our case scenario, the external demand is expected to be 2,300, 1,400, and 1,650. So 2,300, 1,400, 1,650. The reason we're inputting all these amounts are because then we can just link our formulas based on these amounts by inputting them once, and we won't have to type them in again and again, which will avoid possible typos and will save us time later on, even if it's taking us time right now. And this, as it mentions, the order for road wild is not included in the demand estimates above, and it's 200 pairs of shoes for each type of shoe. So 200 each over here. And we can make a separate calculation here for the total number of pairs, just to have that number ready to go for our formulas as well. Okay, so now we need to calculate the requirements. So total material required, which will be, you take the materials per pair and multiply it by the total number of pairs for each of these products. And what we'll do is we'll fix the formula so that we can copy it down below for the labor hours and machine hours as well. So 6,930 is the total meters required, total material required. We'll just mention that. This is in terms of meters. Then total labor hours required and total machine hours required. And we can just copy this formula down below. Basically, for labor hours, once again, for each product, we're multiplying the labor hours per pair into the total number of pairs, same for machine hours. So we have our totals here. We will compare these to the capacity that we have. Available capacity was 7,200, 6,900 and 1,815, which we can see from this table over here. So we can see we have enough material because the capacity is 7,200, we only need 6,930. We have enough labor hours, the capacity is 6,900, we only need 6,750, but we do not have enough machine hours because the capacity is only 1,815, we need 1,875. So we can say, thus, machine hours is our limiting factor as we require more than the available capacity in order to fulfill our entire demand requirements. Okay, that's the first part of the calculation. Now that we know the limiting factor, we're going to find the contribution per unit, contribution per limiting factor, and so on and so forth. So we'll copy this down below. We'll start by including the contribution per unit. Once again, we'll need to go to the table above. Remember, contribution is selling price minus variable cost. In this case, we have the selling price minus all these variable costs, and we have the fixed cost and the profit. So what we can do is a quicker calculation would be profit plus fixed cost, as that is the same as selling price minus variable cost. So for road, it's 37.5 plus 4. For spikes, it's 23.5 plus 6. And for trail, it's 32 plus 4. Now remember, for the order for the run wild order, the selling price is at a discount of 8. So if the selling price goes down by 8, the contribution will go down by 8 as well. So we'll make another contribution per unit. So this is the regular one, and this is the one for the road wild order. And this will simply be 8 less than the regular contribution. Once again, it's best to show these two separately in one place so that we can then use it in subsequent calculations. Then we need to find the contribution per limiting factor, which is of course machine hours. So we'll just say contribution per machine hour. For this, we'll simply take the contribution per unit up here divided by the, oh sorry, it's not the contribution per unit, it's the contribution per pair. We should be consistent with our wordings so as to avoid any confusion for the marker. So it's going to be contribution per pair. So we'll take the contribution per pair divided by the number of machine hours per pair for each of these. and we can see that the ranking is, the highest is for spikes, so that's first, then it's trails, so second, and then it's the road shoes, which are third. We'll put this in bold because this ranking is an important part of our answer. We'll also mention this part, the limiting factor part, in bold as well, because that's important as well, so the marker can immediately see these things. Okay, so we have our ranking, but first we're going to have to fulfill the order, and we now need to dictate the optimum production plan and resulting total contribution. So we need to tell them both sides of the story. One, how many pairs of each type of shoe will be sold based on our limited number of machine hours, and then how much contribution will be earned as a result. So what we're going to do is we're going to start with our total machine hours available, which are 1,815. Then we have machine hours needed for run wild. The machine hours needed for the run wild order are basically, there's 200 pairs needed for the order multiplied by basically the number of machine hours per pair for each product. Since it's 200 for each, we could simply do 200 into 0.4 plus 0.3 plus 0.2. If that's fine too. It's up to you if you want to do it that way or you want to just put these amounts in individually. The reason I'm putting them individually is because the formula then is more easy to follow. Otherwise the marker might for a moment get temporarily confused as to why we just picked 200 once and the machine hours prepared multiple times. So that will be remaining machine hours after that will be 1,815 minus 180. So 1,635 machine hours will be left after fulfilling our order for run wild. After that, we will try to make as many units of spikes as we can. So the total number of units of spikes we can make based on the external demand is 1,400, requiring 0.2 machine hours per pair. So machine hours needed for spike will be the 1,400 times the 0.2 over here. We can see this is only 280, so we have remaining machine hours. We can copy this formula down below. We still have 1,355 machine hours left. Second in rank was trail, so machine hours needed for trail will be the number of pairs, 1,650 into 0.3, which will give us 495. Once again, we'll just copy this part below, which gives us 860. Now the last pair is road. For road, the total hours required would be 2,300 into 0.4, 920. So you can see we don't have enough, we only have 860 hours left. So we can say we will be unable to fulfill our external demand for road. We would only be able to produce in as many pairs as we can within 860 hours, and this would be pairs of road produced for the external demand. We would take the 860, we have 860 hours, and how many hours is needed per pair? It's 0.4, so we'll multiply 860 into we'll divide 860 by 0.4. That means we'll be able to produce 2150 pairs out of the total 2300 pairs. So now we can mention our optimum production plan. Thus, the optimum production plan is to first produce 200 units of each hue, 200 pairs, of each hue for the road wild order, then we will produce the full external demand for both spikes and trail. We will then end by producing 2150 pairs of road. So since this is the optimum production plan, part of the requirement, we'll put this in bold, and we'll move on to our last part, which is the total contribution under this plan. So the total contribution, we will perform two separate calculations to make our job easier. For the road wild order, the total contribution for the external demand, and then the total contribution overall. So the total contribution for the road wild order will simply be, we'll take the 200 pairs produced for each and multiply it by the contribution per pair as per the road wild order. We need to be careful here. So once again, so you see how it was helpful for us to show all the numbers previously separately and individually, so that now we can just link everything as per our formula and not make a mistake. So that's the contribution. We'll get 16,600. Then for the external demand, again, for road we'll only produce 2150 pairs and the contribution per pair will be 41.5. And for the remaining two, we'll reduce the full demand, so we'll go back up to the total external demand. So for spikes it's 1400 multiplied by the contribution per pair, and for trail it's the same story, 1650 multiplied by the contribution per pair of 36, and we will add these two amounts up to get 206,525. Okay, so that's part A, part 1. As you can see, it took us quite a bit of time, but you'll see that the other parts are more analysis heavy parts, or the calculations are more straightforward, so it won't take us too much time and we'll be able to catch up. Okay, so let's move on to part 2. It says calculate the maximum financial penalty Bella Houston Co. would be prepared to accept from Runwild if it does not complete Runwild's order in full. So remember what they said, Runwild would charge a penalty to Bella Houston if they do not fulfill their order in full. Now, how would we calculate the maximum amount of penalty they'd be willing to pay? Well, if they were to break the agreement with Runwild, how much more money could they potentially make? That's what we're looking at. So what will happen is we will simply take, this is going to be part 2, so we'll label it total contribution, external demand. Now keep in mind, we required 180 hours to fulfill the order of Runwild. We only needed 60 more hours to complete our external demand for road. So we'll mention this. We needed 180 hours to fulfill the order for Runwild and fell short by 60 hours. Let's move this down to fulfill our external demand for road. Now, why would we want to break the agreement? Well, from a money perspective, remember, the run wild order, we're making far less money than we would be for a regular sale. So that's why. But we don't need to just ignore the run wild order completely. We can still fulfill it partially, because if we go back to the wording in the question, notice what it says. It says the order is to supply a maximum of 200 pairs of each type of shoe. So just because we're going to break the order doesn't mean we need to break the entire order. We can then use, we will first fulfill external demand, as that is more profitable per pair. The remaining 120 hours can be used to fulfill the run wild order to the extent possible. Okay, so the total contribution for the external demand will simply copy our formula from here, but now we will replace one part of the formula. Instead of using 2,150 over here in the blue cell, we're going to fulfill the entire external demand. So we'll just go up here and take the 2,300 external demand. Now our total contribution becomes 196,150 for external demand. Now how much can we fulfill for run wild? For run wild, it makes sense once again that we try to follow the ranking, because now we can't fulfill the entire order. We'll follow the ranking of first, second, third between spikes, trail, and road to fulfill the order as much as possible. We have 120 hours, so we'll fall short by 60 hours on the requirement for the road pairs. So the total contribution for the run wild order I think let's show the calculation as well, even though it's just for 4 marks, we don't need to go into that much detail. It'll be very similar to what we've done here. Let's just add some more cells. So we'll have 120 machine hours available. For spike, we need, there's 200 pairs multiplied by 0.2, which will give us 40. We'll be left with 80. For trail, we need 200 pairs into 0.3, we need 60, and we have remaining 20 hours. For that, we will fulfill as much as we can for road. The remaining 20 hours will be used to produce as many units of road, as many pairs of road as we can. Once again, pairs of road produced. This time it will not be external, it will be for run wild. You can see we are just copy pasting our format from above, which we took so much time to make, and now it's helping us in the long run. So we need 20, we have 20 machine hours, it takes 0.4 hours per pair. That means we'll be able to produce 50 pairs. We'll fall short by 150. And now the run wild order, we'll just copy this formula. The only difference is, now in this formula, instead of taking the 200 in cell C8, we will replace it by the amount we calculated over here of 50. So we get 11,575. So that means our total contribution overall will now be 207,725. So the additional contribution earned if we break the order compared to if we kept the order would have been the difference between these two amounts, which is 1,200. So that's the maximum financial penalty we would be willing to pay. That if we are only going to make 1,200 extra dollars by breaking the agreement, then the maximum penalty we'd be willing to pay is up to that same amount. Otherwise, we're making a loss on the whole thing. So the maximum financial penalty acceptable would be up to $1,200. Okay. So the calculations typically for this sort of question do take quite a bit of time, but like I said, the next 9 marks will be quite quick because they'll be simpler and more analysis based. So it says, discuss whether Bella Houston should fulfill Runwild's order in full in March. This is a more generic sort of question, that should they fulfill the order or should they break it? What are some of the pros or cons for each? Since it said discuss, we can talk about both sides. For 4 marks, so we need about 4 points. So let's just quickly write them down. So first things first, by breaking the order contract for Runwild, Bella Houston will be able to earn an extra contribution of $1,200. So that's one good thing. However, it would also incur a financial penalty which may potentially be even more than the $1,200. But ignoring the financial penalty, if you break the agreement with Bella Houston, what will happen? Your reputation will take a hint. Bella Houston will tell everyone they know that not Bella Houston, Runwild will tell everyone they know that Bella Houston is not a trustworthy supplier, they did not fulfill our order, and our reputation will take a hit, and potentially we lose out on other suppliers as well. Furthermore, as you remember in the case, it says, if the first order is successful, Runwild will be keen to enter into a regular supply contract. So this will not only affect this contract sales, but future contract sales as well. Remember, external demand is not guaranteed. It's an estimate. We might be able to hit that amount. We might not, depending on what the demand is in the market. A contract means that's guaranteed sales. And it's better to have guaranteed sales than potential sales or hopeful sales. So we're losing out on guaranteed sales in an attempt to make potential sales. So there's that risk as well. Furthermore, Bella Houston's reputation will suffer as their contract breaking will result in Runwild spreading the news that Bella Houston is not a trustworthy supplier. This could result in lost sales from other potential customers, as well as from Runwild themselves, who could have asked for future orders. And lastly, the breaking of the contract might also result in legal repercussions if Runwild takes Bella Houston to court. So there's all these potential issues that we have. Again, 4 marks, so we don't need to go into more detail. it says discuss whether they should fulfill. So we'll just end with a hint, small advice. So we'll say, due to the possible ramifications or possible harmful results, it would be better for Bella Houston to not break the contract and to continue to fulfill Runwild's order. Okay. So let's move on to part C and quickly wrap that one up as well. It says define the variables and formulate the constraints and objective function meaning the contribution function, to be used in the linear programming model to determine the optimum usage of resources in April for 5 marks. So we just need to give the objective function, the constraint functions, and define the variables. Okay, so we'll start by defining our variables. Remember, the variables are based on the products that we're making. In this case, there's 3 types of shoes. We have road, spikes and trails. So we'll simply use the same letters for simplicity's sake for each of them. So we can say R is equal to number of pairs of road, S is equal to number of pairs of spike, and T is equal to number of pairs of trail. Then we have our objective function. We'll put a heading there, objective function, and we'll put another variable as well. C is equal to total contribution. So C is going to be equal to the contribution for each of these multiplied by the number of pairs. In this case, it's for resources in April, meaning after March, after Bella Houston has fulfilled Runwild's order. Let's just go back to the question to see if there's any other information they've given us for April. Demand and resource availability for April. Bella Houston predicted that the resource availability in March would continue into April. However, it has been discovered that the availability of direct material and direct labor will be 15% less than in March. So material and labor will go down. The available machine time and demand estimates are unchanged. Runwild will not be placing an order in April, so we'll be using the contribution per pair for our regular external demand, which is 41.5, 29.5 and 36 for each respectively. So C is equal to 41.5 R plus 29.5 S plus 36 T. So that's our objective function. The other part of the requirement, we need to remember that materials and labor are 15% less for this, are that formulate the constraints. So we'll say constraint functions. So for materials, it's going to be 1.5 meters per pair for road, so 1.5 R plus 0.6 S plus 1.2 T. So 1.5 R plus 0.6 S plus 1.2 T, right? And this will be less than or equal to the total amount of meters we have available. We have 7,200 available in March, but it'll be 15% less in April. So we'll take the 7,200. We'll just show this calculation here. 7,200 times 1 minus 15% or 85%. That will be for meters, and this will be for the other one, the labor hours. And the final one will be, of course, machine hours. So this will be less than or equal to 6,120. Then for labor hours, once again we'll take the amounts 1 R plus 1.5 plus S plus 1T. So 1 R plus 1.5 S plus 1T is less than or equal to 5,865. And lastly, for machine hours, the capacity or supply was 1,815, and it was 0.4, 0.2, and 0.3 machine hours per pair. So 0.4 S plus 0.2 S plus 0.3 T, sorry, 0.4 R, and this will be less than or equal to 1,815. Okay, so the last constraint function, which we must always mention, the non-negativity constraint, which is R, S, and T must be greater than or equal to 0. You cannot have a negative number of units produced. Of course, since they've given us the external demand, we would need to include constraints for external demand as well. Which will simply be the same as the demand numbers from above, because the demand they said would not change. So 2,300, 1,400, and 1,650. So R is less than or equal to 2,300, S is less than or equal to 1,400, and T is less than or equal to 1,650. Right? Let's just double check once more. 2,300, 1,400, and 1,650. Okay, so we have all of our constraint functions and all of our numbers here as well. So as you can see, the final 9 marks, which were parts B and C, took much less time than the first 11 marks of the calculations, even though there was a rough split of marks. So the calculation for such a question will always be long. There was a similar question in one of the previous past papers as well, which followed the exact same format. That part A was for the long calculation for the optimum production plan, and there was a external order, and we needed to find the total contribution. Then there was a part B in that question as well, that if they break the order, what are the consequences? And part C was more towards the linear programming side, although in that question, because it's before the CB exam, I believe, they had given a linear programming graph, and we needed to answer questions based on the graph itself. So the calculation, as you saw, it's straightforward once you know what to do. It's just a matter of making sure you take in all the requirements and all the tricks, like there being first having to fulfill the order, having to calculate a separate contribution per unit or per pair for the order amounts, etc. Right? We need to consider all those particular variables in place. But apart from that, even though the calculation is long and it takes time, once you get the hang of it, you'll be able to still finish the question in time, as you see that we've been able to do. And obviously, you'll be able to make up most of the time in the second and third part of such a question, because that won't take too much time. Okay, so I hope this benefited you guys, and I'll see you guys next time.